Hi, Precalc. We're back. I want to start practicing from this section a problem like I would ask you on the test. This first one is not as complicated as I would ask you on the test, but the second one will be, okay? So I want to just start with an easier, sorry if this fades in and out, it'll fix itself. I want to start with an easier one because I want you to get the idea. All right, so let's go ahead and give this a go. So what I would want you to do is to algebraically find the inverse, okay? So I just want to start with something really nice and easy so you can focus more on the concept versus the level of difficulty of the problem. So this function is linear, this is a line. I'm going to now find the inverse. I just want to state for the record, I'm making an assumption here that I want to be very clear about. I mean, I know it for a fact, but I want you to make sure you understand it. Because this is a line, it passes both the vertical and the horizontal line test. So this has an inverse. So it's not like I'm guessing. I know this function has an inverse. That's why I picked this. So this is the steps I want you to do. First, instead of calling it f of x, rewrite it as y. Okay, so rewrite it as y. Now this is the biggest step right here that you're going to do. You're going to swap x and y. Okay, when I say swap x and y, that means that you're exchanging the domain and the range. And when you do that, that's actually what makes the inverse. See here, I swapped x and y. This is the most important step. This is the inverse right now, actually. Because the moment that you swap these variables, you've made the inverse. This is crucial. After that, we're just formatting and making it look pretty, okay? So now I'm just formatting. So now I'm going to solve for y. So I'm just going to bring the 4 to the other side. I'm going to divide off the 2. I'm just going to rewrite this because most of our brains like the y on the left side. All right, now this last step, I'm just going to state that it's the inverse. When you first see this notation, you may not like it, and I don't blame you because this may look to you like it means reciprocal because of the -1. Usually that negative exponents mean reciprocal. But in function notation, this actually means f inverse. This is read f inverse. And that's really important to know that because when you see the book tell you inverse, they're going to write it like this. Now, for those of you who are really particular about the mathematics, this is how you would write reciprocal in function notation. This guy means reciprocal. This guy means inverse. It's almost the same thing, so it's like mind-boggling. But if you put these like little parentheses here, you're saying you want to reciprocate. This means inverse if you just throw the little -1 up there. All right. So this is the inverse. So how you do it again, let's go through the steps. You swap x and y, and then you solve for y, and you label it as the inverse. That is the steps. Now here's another thing I'm going to ask you to do, so please make sure you catch it. When you take... Oh, you know what? I'm going to have to back up. I jumped over a step. My apology. I will come back to that. My apology. Let's come back to here for a second. Let me just not get your brains going in every direction. Okay. So two things I want to say here. The first thing I want to say is if you're going into STEM, your math, science, technology, engineering, one of those, here's a cool observation. Notice the original function was a product and a sum. You're multiplying and adding. You would multiply first, add second. The inverse is the opposite, operations. So here we have multiplication, here we have division. Here we have addition, here we have subtraction. Right? Okay, so not only is it the opposite operations, it's the opposite operations in the opposite order. Here you would multiply first, add second. Here you would subtract first, divide second. Okay, sort of cool. If you're not mathematics or STEM, don't worry. You know, I know I'm putting everybody on overload. Okay, but that's sort of cool if that's your thing. All right, next thing I want to talk about here, and again, it's only like super obvious if the functions are basic. Once the functions get too fancy, it's really hard to see that it's that opposite operations in the opposite order. Okay, gang, let's draw this because I also want you to make some visual connections, which are important. You can actually look at two graphs that are overlaid and see if they're inverses. You would know right away. All right, let me make a table here for f, so x and f of x. I'm just going to make some points for this guy. So if x is 0, y is 4. If y is 0, x is -2. Let me just see if I want to put anything in the middle of that. I got 0, -2. Maybe let me do 2 and 8, 2, 4, 8. Okay, let me just see what that looks like if I like that choice or not. 1, 2, 3, 4. -2. You know what? I want to come more to the left. Okay. Let me do, what did we do? -2. Let me do -4, which would then give me -4. -8 plus 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4. About there. Okay. About right there. You're gonna have to just bear with me here with my line. Okay. Now, this is the original function. The moment that you wish you had a ruler. Okay, this is the original function. Now, without making any thinking at all, no thinking at all, can you figure out what might be 4 points that are on the inverse? Without any thinking, just flat out in 1 second. Okay, hopefully you made the observation that if they're inverses, what makes an inverse is the domain and the range swap. So that means that all the output values of the original function, the range becomes the domain, and the domain of the original becomes the range, right? Because that's what makes them inverses. Their domain and range is very intimately linked. Their domain and range is opposites. That's what makes them inverses. It's very cool. So now let me graph this guy. Okay, so as I'm doing this, see if you can make some observations. What you're seeing is not a coincidence. It's not an accident. All inverses will have these same observations. So I can look at two graphs and know right away if they're inverses. They have very particular type of symmetry. Does anybody see it? Okay, hopefully you see it. They will reflect around the line y equals x. They are equidistant between the line equals x, which means if you flip one over this line, it will land right on top of the other. Okay? So inverses are symmetric about the line y equals 2x. So even if I didn't give you the equation, and I gave you this graph, you could find the pink one. You could do it just graphically, knowing that you would just flip the points. Okay, so that's a super cool observation. All right, last little bit on this one, and I do want to do a more difficult one with you, but let me just, let's just do this one. So what I'm trying to say here is if you want to verify that two functions are inverses, you would use this concept. So what this says is that if you do something to a function, the inverse should undo it. So if you apply both, if you have something and you apply both the original and the inverse, they will totally undo each other because they're opposites. So like if I wrap a gift and then I unwrap a gift, I have the original. So technically you're supposed to go in both orders. That's what this is saying. First make F the outer, G the inner, then make G the outer, F the inner, and then if you take the composite, they should undo each other and you're left with X. So what makes the two functions when you take a composite, what makes them the inverse is that you're left with X. They undo each other. So it doesn't really matter which order we do the linear one in. It's so simplistic, it will work both ways, but let me just show you at least one way so you can see it. Here's the original. Here's the inverse. Let's do it so you can see it. On the exam, I'm only going to ask you to do it one way. So I'm going to verify this. I'm going to prove this concept doing it just this way. So I'm going to stick, oh, sorry, let me write this. I'm not being as clear as I want to be. Hold on one second. I'm going to do it this way. I'm writing it in terms of F and G. I meant to write it in terms of F and F inverse, so you could see who I'm putting it to. I'm going to put F inverse into F. But again, the opposite order will also give you X, okay? This is what I'm trying to say here. It doesn't matter what order you do it in, it's going to give you X. Okay, so F, I'm taking this one and putting it where the X is. That's what I'm doing, okay? I'm stuffing this into this. We talked about composites in 1.8 just a few moments ago in the previous video, right? This is, I'm doing it now. I'm doing the composite now. All right, so here I go. So the original, let me see if I can zoom out a little bit here. The original is 2 times something plus 4, right? 2 times something plus 4, but the something I'm putting in here is this fraction. Okay, hopefully you see it. Let me see the best way to write this. Okay, maybe I can just do it from here. Maybe I'm trying too hard. All right, so the 2 and the 2 will go, right? You were multiplying by 2, you're dividing by 2. And then you're left with X minus 4 plus 4. So now the minus 4 and the plus 4 go, and you're left with X, right? And that is the verification that they're inverses. That's the verification that they're inverses. I'm going to finish this video in... you know what, actually, let me just finish it here. I'll pick up in the next video. Okay, so just make sure that you can find the inverse and verify that they are inverses. I'll do a harder example in the next video. Catch you. Bye-bye.